Welcome to Bonhill Geography. In today's lesson we are going to focus on the long and cross profiles of rivers. Today we'll explore the key features and the processes that shape rivers from their source to their mouth. Now rivers begin their journey at the source. This is often found in highland areas. The long profile of a river shows the gradient from source to mouth. At the source the gradient is steep and the river has a lot of potential energy. In the upper course, the river flows quickly down steep slopes, creating V-shaped valleys like we see in the background here. These valleys form due to vertical erosion, where the river cuts down into the riverbed. The steep sides of the valley are a result of the river eroding downwards faster than the sides can collapse and widen. Weathering also plays a crucial role here, breaking down the rocks on the valley sides through processes like freeze-thaw and biological weathering. Sometimes you can even see remnants of these rocks. We call this scree. In the upper course, the river carries large angular boulders and rocks which help to contribute to erosional processes. The key erosional processes include hydraulic action, abrasion and attrition. The water flow is fast, with speeds ranging from 1.5 to 3.1 meters per second, and the discharge is relatively low, typically from 0.1 to 10 cubic meters per second. This is important to remember. Fast moving water, but not very much of it. Now as the river moves into the middle course, the gradient becomes significantly less steep. The river starts to meander, forming wide valleys with gentle slopes. These valleys are shaped by lateral erosion, where the river erodes the sides of its channel, making it wider. Weathering continues to break down the valley's sides, contributing to the gentler slopes. The sediment carried by the river becomes smaller and more rounded due to attrition. In the middle course, deposition also begins to play a role, creating features like point bars and floodplains. The combination of erosion, weathering and deposition results in a more open and gently sloping valley. The water flow slows down, with speeds ranging from 0.5 to 1.5 meters per second. And the discharge, however, increases to around 10 to 100 cubic meters per second. As a reminder, this is because there's now more water, even though it's technically moving slower in meters per second. Now in the lower course, the river flows over a gentle gradient towards the sea. This area is very flat, but the river channel is wide and deep, and deposition is the dominant process. Here we'll find features like levees, deltas and estuaries. The valley in the lower course is very wide and flat, as previously said, formed by the extensive deposition of sediments over time, which builds up floodplain height. Weathering continues to break down any remaining higher ground, contributing to the flat valley sides, sometimes described as a very wide U-shaped valley. The sediment in the lower course is very fine, such as silt and clay. This is easily deposited as the river loses energy. This is why it's typically found that estuaries are quite muddy. The water flow is the slowest in meters per second, ranging from 0.1 to 0.5 meters per second. And the discharge is the highest because there's lots of water here, typically exceeding 100 cubic meters per second. Now, let's look at the cross profile of a river. The cross profile shows a cross section of the river channel and valley at different points along its course. In the upper course, the cross profile is very narrow and deep, with steep valley sides due to vertical erosion and weathering. The river carries large angular rocks and boulders, as previously stated. In the middle course, the valley becomes less V-shaped and more U-shaped. The cross profile becomes wider and shallower, with gentler valley sides due to lateral erosion from those lovely meanders talked about earlier, but also weathering and deposition. The sediment size we can expect to be smaller and more rounded, as we can see in the background here. By the time we get to the lower course, the cross profile is very wide and deep, with flat valley sides formed by extensive deposition and continued weathering. The sediment is super fine, such as silt and clay, again previously mentioned earlier in the video. Let's now touch on the key processes you need to understand for the river's topic. First, hydraulic action. This is the force of the water breaking rock particles away from the riverbed and banks. This will gradually weaken it. Next, we have abrasion. This is where rocks carried by the river grind and wear down the riverbed and the river banks. Next, we have attrition. Rocks being carried by the river smash together and break into smaller, smoother pieces. Lastly, there's deposition. This is the process by which rivers drop their loads of sediment. Another important factor is weathering. This is the breakdown of rocks in situ by physical, chemical and biological processes. Physical processes involving onion skin, freeze-thaw and more. Chemical by acid rain, and biological processes normally involving things like plants growing and their roots digging into the face of rock. For transportation, traction is when large boulders and rocks are rolled along the riverbed due to the force of the water. Sometimes rocks can remain for a long period of time until a flood occurs, and then only move later. This is typically what happens in the upper course. Next we have saltation. This is typically where small pebbles and stones are bounced along the riverbed, almost like a leapfrog in motion. Next, suspension. Fine particles like silt and clay are carried within the water. This can typically make it look quite muddy. Now it's important to remember here that this is normally happening in estuaries where all of the eroded material is finally transported downstream. Our last transportational process is solution. This is where dissolved minerals are transported within the water itself. This can also be defined as an erosional key term, where rock or sediment is dissolved to be put into a solution. So as is clear, as we move downstream, the rates of erosion and transportation change. In the upper course, vertical erosion is dominant due to the steep gradient or gravity and high levels of energy, which allows the river to carry large angular rocks. In the middle course, lateral erosion becomes more significant, and the river transports smaller, more rounded sediment grains. By the lower course, the river's energy is very, very low, so energy has decreased. That's not only due to the lack of steep slopes or gravity, but also just because it's very flat and very wide and very deep. This leads to more deposition of fine sediments like silt and clay. The river's ability to erode and transport material decreases as the gradient flattens and the flow slows down even further. Here's a summary slide for your notes. Do not worry about the specific flow rates or QMEX or cubic meters per second, but this should help you in your revision if you need it. Here are some example questions and model answers. Please feel free to pause here if you want to practice them or check what you would have got within your response. Thank you for watching Bonhill Geography. I'll catch you in the next video.